Question 2 is our integration by substitution question. So I always start on the right hand side of my page taking this substitution. So they've asked us to use a substitution that x equals tan theta. We differentiate this as it is. So dx by d theta is what you get when you differentiate tan. And when you differentiate tan theta, you get sec squared theta. So that means that dx is sec squared theta d theta. Okay. We're also, it's a limits question where it's a definite integral. So at the same time, these are my x bounds, I'm going to convert these to theta bounds. So when x equals root 3, theta is going to be the inverse tan of 3, making sure you're in radians for integration. Inverse tan of root 3 is pi over 3. And when when x equals 1, the inverse tan of 1 is pi over 4. So I'm just setting the whole question up at the moment. So we want the integral between pi over 3 and pi over 4 of, what have we got? We've got 1 minus x squared, but that's tan squared. So we've got 1 minus tan squared theta over 1 plus tan squared theta times by dx, but that is sec squared theta d theta. Okay, so that looks an absolute mess. But what can we do? Well, we also know that a link between tan squared and sec squared. We should hopefully definitely know that sine squared theta plus cos squared theta is 1. And so because that's true, if we divide all of these terms by cos squared theta, we get that tan squared theta plus 1 equals sec squared theta. So you can see now that this can also now be rewritten as still pi over 3 and pi over 4. 1 minus tan squared theta, but tan squared theta is the same as sec squared theta plus sec squared theta minus 1 over 1 plus tan squared theta, but tan squared theta plus 1, or 1 plus tan squared theta, is sec squared theta. Sec squared theta d theta. So you can see now that these sec squared thetas disappear. So that then gives us, still between pi over 3 and pi over 4, just this top expression here. And if I get rid of the brackets, I'm going to have 1 minus sec squared theta minus 1. So that's 2 minus sec squared theta d theta. And now we're ready to integrate. We can integrate to 2. Integrate 2, we get 2 theta. Integrate sec squared theta is tan theta. We know that. We use that in the very first part of the question, that when we differentiate tan, we get sec squared. So when we integrate sec squared, we get tan. Between pi over 3 and pi over 4. So putting in the limits, we've got 2 pi over 3. Take away tan of pi over 3. Take away 2 pi over 4 minus tan of pi over 4. Tan of pi over 3 is root 3. Well, that's just pi over 2 here. And tan of pi over 4 is 1. So we have got 2 pi over 3 minus root 3 minus pi over 2 plus 1. And you could group your pi's together, so 2 pi over 3 take away pi over 2 is pi over 6. So we've got pi over 6, take away root 3 plus 1, but that's my final answer. You can't simplify that anymore. Notice, I didn't even check, but I assume it said exact. Yeah, it asked for the exact value. You're never going to want to find a decimal value of this. It's always going to want to be an exact form, so don't reach for your calculator too early and type all of this in one go, because you will get decimal answer. You need to work out each